So, Raspberry Pi has dropped the successor to the wildly popular RP2040 chip. It's called the RP350, and while it's absolutely packed with new features, well, the story here isn't quite as simple as just new and improved.
Okay, let's really dig into this. We're going to break down the promise versus the reality of this chip everyone's been waiting for. We'll look at its power, some really surprising performance numbers, and a glitch, a flaw baked right into the silicon that has the entire maker community talking.
All right, so first, let's set the stage a little. To really get why the RP2350 was such a big deal, you have to remember just how much of a splash its predecessor, the RP2040, made. I mean, when the RP2040 came out in 2021, it was a complete game changer. It had a dual-core processor, and its killer feature, the programmable I/O, or PIO, gave developers this insane flexibility to basically create custom hardware interfaces in software. All of this for a super low price. It really did start a revolution in the hobbyist world. So you can imagine the hype for the new RP2350 was just massive. Raspberry Pi's own CTO basically said this was the chip they always wanted to make, that the RP2404 was just paving the way for this one. The community was ready for an absolute home run. And man, when you look at the spec sheet, you can totally see why. On paper, the RP2350 is an absolute beast. We're talking some serious upgrades across the board, way more than just a simple speed bump. This chart just lays it all out, doesn't it? We've got faster, much more powerful cores, nearly double the RAM, more PIO state machines for even crazier projects, and look at that last row, a whole suite of security features like ARM Trust Zone. This wasn't just a chip for hobbyists anymore. This was aimed squarely at professional, secure applications. And here's maybe the biggest deal of all, architectural freedom. For the very first time, you could choose to run your code on industry-standard ARM cores or on up-and-coming open-source RISC-V cores. Same chip, your choice of architecture. That was a huge, huge deal. But this is where the story starts to get really interesting. As soon as the chip got out into the wild, the performance story got a little weird and, not in the way anyone saw coming. So think about it. You've got these advanced ARM Cortex-M33 cores with the dedicated hardware unit for floating-point math. Then you've got the simpler RISC-V cores that don't have that. The winner for speed should be obvious, right? It has to be the ARM cores. Well, check this out. For certain tasks, specifically integer-based ones, the opposite happened. In these benchmarks from the ULISP community, the supposedly simpler RISC-V cores actually beat the ARM cores. They finished the tasks faster. A really surprising and, frankly, impressive win for the open-source architecture. But the surprises, unfortunately, weren't all good. Very quickly, developers who were trying to move their old RP2040 projects over to this new chip started noticing something was off. The input pins were behaving strangely, unpredictably. This led to the confirmation of what's called a hardware erratum. Now, that's basically an official admission from the manufacturer that there's a bug, a flaw, baked right into the silicon. This one was documented as RP2350-E9, and it described a very specific situation where an input pin could get stuck. But the community, being the community, dug in, and on places like GitHub, they quickly figured out the problem was way, way worse than the official document described. People were seeing this bug pop up even when those specific conditions weren't met. It was much more common than anyone realized. And you can just feel the frustration growing as people realized this flaw could randomly break almost any project that uses digital inputs. The mood soured fast, leading to some pretty blunt statements online, like this one right here. So what is this bug really? This isn't a software thing you can just patch away. No, this is a physical flaw in the silicon itself. Eventually, Raspberry Pi had to update the official documentation to redefine the problem as something much more fundamental. The issue is now officially called an input mode leakage current problem. Okay, so in plain English, think of it like this. A GPIO pin set as an input should just be a passive listener, right? But with this bug, it can actually leak current, making it act like it's weakly connected to power, even when it's not. And we're not talking about a tiny, insignificant leak. It can be up to 120 microamps per pin. That's more than enough to completely overpower the chip's own internal pull-down resistors, which basically makes them useless and causes the pin to give you a false high signal. And the real-world impact of this? Oh, it's huge. It means you just can't trust those internal pull-downs. It means you might have to add external resistors to your design, which adds cost and takes up space. It's a disaster for low-power, battery-operated projects. And get this, the official software workaround doesn't even work if you're using the PIO.
Yeah, the consensus from tech writers and just about everyone in the maker community is pretty clear. This bug completely changes things. What should have been an easy, exciting upgrade is now, well, it's a chip with a serious problem.
So this brings us to the bottom line, right? What does this all mean for you if you're starting a new project? With all this power, but also this one big flaw, which chip should you actually use? The choice really isn't simple anymore. Look, if you absolutely need that raw CPU power, the extra RAM, or those new security features, and this is a big and, you can design your circuit to work around the bug with external resistors, then yeah, the RP2350 might still be for you. But for pretty much anyone else, especially if you need reliable inputs right out of the box or you care about power consumption, the original, trusty, and proven RP2040 is still the safer bet. And that kind of leaves us with one final big question. The RP2350 shows so much promise. It really is a glimpse of that incredible chip Raspberry Pi wanted to build from the start. But this hardware bug, this glitch in the silicon, means that for a lot of people, the wait for that perfect microcontroller, it continues. The question now is, when will we see a fixed version? And will that be the chip everyone was truly waiting for?